are live on YouTube. Hello everyone, welcome back. And let me check if we are live on all platforms correctly or not. Yep, we are live on Twitch. And I think we are live on YouTube and I think we are live on YouTube and we are live on X as well. YouTube, we are live on X as well. Okay, so let's get started. Let me share my screen. We are solving LeetCode problems using Python, and then we are using Grok / SuperGrok to help us get clarity whenever we get stuck. So I am solving this list top to bottom. That is, we are starting with the array and strings. I have already solved those questions. I have also solved all the questions in the 2 pointers. And then I have reached sliding window, which had some hard questions. We are leaving the hard questions for the end because I don't want to dwell on those for too long. Then we have the matrix. We solved all of the questions there. We solved all of the questions in hash map. Currently we are at intervals. Yesterday we solved 3 questions in intervals, which was summary ranges, merge intervals, and insert interval. Now we have another question which is of medium difficulty. Minimum number of arrows to burst balloons. Let's get started with that. These are some spherical balloons taped on to a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points where we have the start and end. We don't know the exact y coordinates. We just know these are the points that the balloon stretches from x to x, from position x1 to x2. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with the x start and x end is burst by an arrow shot at x if it's in the range. There is no limit to the number of arrows that can be shot. So if you want to brute force this, just shoot all of the arrows at all of the locations, and then you will burst all the balloons. A short arrow keeps traveling up infinitely, bursting any balloon in its path. Given the array points, return the minimum number of arrows that must be shot to burst all the balloons. So we have to find that what are the overlapping points that can be merged into one. So 10 to 16 and 2 to 8 does not overlap at all. So we have to shoot 2 arrows for these. But 1 to 6 and 2 to 8 does overlap from 2 to 6. So we can shoot both of these using a single arrow. And then for 7 to 12 and 10 to 16, these again overlap. So these can be shot using the same arrow as well. Right. So one thing that comes to mind is we can sort all of these. And then we can we will get something like 2, 8. Sorry, we will sort based on the initial position. So 1, 6, 2, 8, 7, 12, and then 10, 16. Then we will start iterating from the index 0, that is 1, 6 is our first balloon. We will see if this overlaps with the next one, right? Then we just get the minimum of like, what is the minimum overlap? So we just take overlap. So this will become 2 and 6 because this is the only part that overlaps. And then one balloon, whether it is merged to the right or to the left, doesn't matter. So if we have considered this here, we can just shorten its range from 2 to 6 so that this just becomes one smaller balloon by combining these two. Then we go to the next point. Now here we can see that we could also have combined 2 to 8, like these two basically, can also be shot down using a single arrow. But there is no possible way for us to shoot all three of these using a single arrow. So it doesn't matter like how, if you combine these two or these two, because essentially you are removing this overlapping one. So we just combined these two and got this. And then we see there is no overlap in this and this. So this stays the same, 7, 12. And then we check if the next one has overlap. Yes. So then we take these and it becomes 7, 10, 12, because that's the range, that is the minimum overlap. And then we say we just need 2 arrows to shoot this down. Let's try to apply the same thing. Here we can directly see it was sorted. So this does not overlap with this does not overlap with this, and the same goes on. And here there is a case where there is an overlap in the boundaries. So 1, 2 and 2, 3 can be combined into just 2, 2, right? It starts there and it ends there. The overlap boundary is just that. And we have merged this into the previous one. And then we can say 3, 4 and 4, 5. This can be merged into 4, 4. This is our overlapping boundary. And then we need 2 arrows for this. And one way to simplify this would be maybe just we start with the end position, because after we sort that, you only need to consider that this end position, if it coincides, like if it falls in between this range, or even if it goes after this. So we will just check if the end of the previous interval is like, if the end of the previous interval is smaller than the start of the current interval, then we just say a no overlap, and we can safely insert the previous one in the results. Or we can have results is we start with, let's see if we have minimum of 1 or not. So there is at least 1 point. So we can start with points 0, and then we can iterate over point in points, starting from the first element and moving to the last, right? And at the end, we are supposed to return the length of results, right? So we can also maintain a counter, but I think this works for now. And then for each point, we will check if the point start is greater than the last thing we have. So the last thing we have, the end of it. So if it is this case, then we can say that there is no overlap, right? And you just add it, keep the results the same, and move to the next thing. Else, we say there is overlap, and we need to update the last entry, considering the current point. Right. And here we will just say that the last entry is no longer required. We can just start considering the current one. So insert the current point in the results. So we will say results.append point, and otherwise we will say that give me the results give me the last element, right? It's both start and end, and then the start will become the maximum of the starts, so max of the current value and the one we are looking at, so point 0, and then the ending will become the current value or the point we are looking at, the minimum of that, because we are finding the minimum overlap between both of these points. And then at the end, do we need to add another point? Because let's say we have this no overlap scenario, and we go 1, 2 is already there. We come to this, there is no overlap, we insert that. We come to this, there is no overlap, we insert that. There is no overlap, we insert that. In this situation, we just had these two. There is overlap, so there is no need to insert anything. So I guess this can just stay the same, and then we can run. It works. Let's try submitting it once to see if our approach is correct or not. Okay, so we need to sort it first. Points.sort key is equals to lambda. For each x, we are sorting by the 0th element. And then you need to do this as the first point. Let's take this as a use case and then try running it. It works. Let's try submitting it. Okay, so it technically works. Now, one place where we can improve is this results, because we are not utilizing the whole results array. We don't care about that. We just need the count. So we can just say count, and that starts at 1 because we always have the 1, the first position. Then instead of maintaining the whole results set, we can just say start and end is just points 0. So this will become our start and end position. And then for each point, we will compare if it starts after the end of the current interval, right? Then we just update the start Then we just update the count to 1 because we know we will need another arrow for this one. We update the start to 0.0 and end to 0.1, right? And then we also need to update this. Now here, basically we can do both updates, which will be the max of the start or the 0.0, and the end will be the minimum of these, the minimum of end and the points end. But since we are not using the start at any point for any comparison, I think we can also comment this out. And at the end, we can just return the count. Let's try and see if this works or not. It works on the test cases. Let's try submitting it. It works on the submission and it is much faster than our previous approach of handling, like maintaining the whole array of the minimum overlapping points. Now what we can just do is just maintain the count and go based off on that. So this solves our problem. Let's try to look at some solutions to see how other people have approached this problem. Um, they sorted this as well, but they sorted it using the P1. Then they did answer and arrow 0. For start and end in segments, if answer is 0 or start is greater than arrow, answer is answer plus 1 and arrow becomes the end. So instead of counting the overlap, they are just putting an arrow where the end is. And if it overlaps, if we burst the balloon beforehand, then it's okay. You don't need to count this. You don't need to count this, but you do need to count this one. What if an end is here and another end is here? What happens in that case? Okay, the start is greater than arrow. So whenever the start goes beyond this point, we say that you need to put another arrow at the end of this one. Got it. I think this is still a bit more approach that you need to think more about rather than like find the minimum overlap and then just go based on that. So this concludes our intervals section. We have solved all 4 problems in this. In the next section stack, we have 5 problems. One of them is hard. We are going to solve the 4 questions, the first 4 questions, 1 easy and 3 medium ones, and leave the hard one for the last. Let's get started with the first question, which is an easy one, valid parentheses. I guess we all have seen this question. It's in the first few questions of LeetCode. Given a string S containing just the characters this, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So this is the incorrect thing because we get the first opening one and then we get the closing, but it's a different type of closing bracket, so we get false. These type of things and this nesting and this sequencing gets a little bit more complicated. So for that stuff, we have a data structure called stack. The data structure stack is last in, first out. Right. So we have a stack of things we have the opening braces, then we get the closing braces. So for all the opening braces of any type, we already have a list of whatever brace types we have. We can just keep inserting things in the stack, and then as soon as we see an closing bracket, like the closing round bracket, curly bracket, or square bracket, we start removing the elements from the stack and checking if they are the corresponding opposite of this or not. And if they are not the same, then we need to return false. Otherwise, if we reach the end of the string, then this is correct, and you can confirm that this is a valid set of parentheses. So one way to do it would be to first we need to iterate over the whole string. Right, we need to iterate over the whole string, and we need to go character by character, and we need to check if it is an opening bracket or a closing bracket. Right, so for this opening and closing, and for mapping this, we can just create a dictionary of mappings. And in this dictionary, we have that the closing round bracket corresponds to the opening bracket. And similarly, we do this for every pair. We have the closing curly braces corresponding to the opening curly braces, and then the closing square brackets corresponding to the opening square brackets. We have our mapping. We will go character and string, and then we see uh, if our character is in mapping, right, then we need to check if the last thing we inserted, if the last thing we inserted is the corresponding bracket or not. Right, so we'll say first we also need to maintain a list. We can implement a stack using a list. So we'll say just call it a stack and it will be a list. If it is not in the mapping, we will just insert things in the stack. We will just append character. Otherwise, we will say if stack is empty. So if not stack or stack -1 is not equal to the mapping corresponding to the character, we return false. Else we say stack. How do we remove the last element? Do we do pop? Can we do pop? How can I remove the last element from the list in Python? We can do pop. That's good. What are the other ways? You can use slicing. I don't think that makes sense here. We can delete the last element. Which method is the best? Pop is often preferred when you need to remove the value. Slicing is efficient for creating a copy. So we just need to remove the last value. So we will just do stack.pop. And if we reach the end, we can safely return true. Let's see what we missed or if we missed anything. So this works on the test cases. Let's try submitting it once. We didn't handle that. We just got opening braces. So we also need to check return stack is empty. So we'll say length of stack is equals to 0. Let's try running that. We'll also add a test case of just opening braces. Try running on that. So we need to make sure that all of the opening braces are correctly closed. Otherwise, it results into false. There might be a simpler one-liner Python solution for this. Our solution is okay, but let's see what other people are doing. They have created a simple stack, a simple dictionary as well. They're going in all of the characters. Then they are saying if the character is in values, so we don't need to check that. We can just go with a simpler check. If the stack is empty or it is not in this. So one thing they have done is instead of checking like this, pop also returns the last element. So we can just put this right here. And then that simplifies things a little bit as well. Because we don't need the last character. We're going to return false anyway if it's not true. And then they are also returning if the character is something else, so not in the braces, then we also return false, but we have here a condition that the characters are only parentheses. So we don't need to do that essentially. And then they are returning if the stack is basically 0 of length or not. Good, this was an easy question, so we were able to move through it pretty fast. Let's move on to the next question in our stack list. Knowing which list you're solving makes things easier because you know exactly how you need to approach it. That allows you to practice the data structures and algorithms without worrying too much about that this can be solved using a linked list or a graph or something like that. So that's why I prefer this approach. Obviously, it's not ideal, but if you are trying to keep things easy, this works the best, I would say. For our next question, we have simplified path. We are given an absolute path for Unix style file system, which always begins with a slash. Our task is to transform this absolute path into a simplified canonical path. A single period represents a current directory. Double means the previous or parent directory. Multiple consecutive slashes, such as these, are treated as a single one. Any consecutive periods that does not match the rules above should be treated as a valid directory or file name. For example, these are directory or file names, right? The simplified canonical path should follow these rules. The path starts with slash. Directories within the path must be separated by exactly one slash. The path must not end with the slash unless it's the root directory. The path must not have any single or double periods used to denote the current or parent directory. So return the simplified path. So it starts with a slash, then we get the name, we remove the last one, start the first one. We only need one slash, so remove one slash, and then we have foo, and then we remove the last slash, home, then we get user, then we get documents, but then we move two parents back. So we remove documents and user. We don't need these anymore. Then we go home and then pictures. So it goes to from here we go documents and then to the user. We only remove one, right? So if it was a single dot, we'll just ignore this, right? And then we get the picture. This does not lead us anywhere. So and this is a valid name A, then you move back to this position, B, and then C, and then you move back to this position, B, and then you move to D, and then you move back to D. So this doesn't matter. So one way I can think of solving this is we will maintain a stack. We will maintain a stack of all the directory names. Tree names. And we will add single slashes at the end. Right, we don't need to worry about the slashes right now. We can just parse them, that this marks an end of a current name of the directory, or we can just simply split on this. What will happen if we split on something like this only? I guess we will get an empty list. And what will happen if we split on something like this? If we get an empty list, that simplifies our work a lot, because then we will only get this. For this one, if splitting on slash works, then for this one, we will get a list of triple dots as a string, and then A, and then double, B, C, and then double, D, single. Right. So if splitting on slash works as intended, then we get this. Otherwise, we will have to parse it. We will move through this list. If we have a single dot, we'll just ignore it. If we have double dot, then we remove the last element from the stack, right? Else, we just append the current directory in the stack. And at the end, we will say I need a string that starts with slash and then joins everything in the stack. Join everything in the stack using a slash. Right. So let's clear our doubts first. Let's try splitting this. We have the path. We can get directories dot split, and we will split based on this. Let's print the directories. And then let's just return the path for now as it is. Okay, so we also get these empty strings. Maybe we can just parse those out by saying directories is directory in path.split if directory is not equals to this. Maybe this can help. Let's also see what happens if you only have a slash and a double slash. Let's try running this. Is it supposed to be directory for directory in? Okay, so we get home. Then for this, we get the both directory names. We get home, user documents, double dot pictures. We get only the double dots. And then we get triple dots, A, double dot, B, C, double dot, D dot that we needed. For the slash, we only get nothing. And then for double, you also get nothing. But this essentially is leading to an iteration, because we are iterating through all of them once. So this is a little bit more time complexity increasing. So we can solve this by parsing each character one by one and maintaining a track of current word, you can say. So let's just do that. We'll keep a stack, or we'll just name the stack directories instead. And then for each character in path, we will go if we also have to maintain the current directory, which is currently null. Uh, if the character is a slash and the current directory is not null, then we need to insert, then we need to perform some operation. Right. Otherwise, if the character is not null, let's split it, because if current directory if the character is not a slash, then we need to append that character in the current directory name. If there is a current directory name present, then we perform some operations, and this will follow the rules that if the current directory is a single dot, then you continue, or at the end, we have to make sure that the current directory is reset to 0, like a null. So we will say if this is the case, don't do anything. So this will be pass. Right. If the current directory is double dots, then we need to remove the last element from stack. Now, one thing is, does pop, how does pop work if there is no other thing? Will pop give an error if there is nothing in the list? Otherwise, if we see double dot, then we need to remove the last directory from our list of directories. Else, anything else is a valid directory name. Then we just need to append that directory name into the directories. So this will become this, and then we'll say that this is okay. I think this should work, this pass thing, but let's see how if it gives us any error. And then we have handled. So we are going, we see the first slash, we do nothing, right? Because our current directory is empty. Then we see 3 dots, we just keep adding those dots. Then we see a slash, we have a current directory. It just gets added. Then we see A, it also gets added, double dot. Then we pop A out of the list. Then we see B, C, which are inserted, then double dots, which means remove C. Then we see D. D is added, and then we see a single dot, which is basically ignored. And at the end, our final path becomes our compressed path, or is it canonical path? Canonical path becomes a slash. It always starts with a slash. And then you join everything that we have in the directories using a slash, and then we return the canonical path. Yes, calling a pop on non-empty Python on an empty Python list will return an error. To avoid that, we need to check if it exists or not. all methods raise an error. So we do need to check and directories. This allows us to simply check if, okay, so this needs to be nested. If directories, then directories.pop. Let's try running this once. And this needs to run at the end as well. If we reach the end and we have a current directory name with us, then we again need to follow these rules. Is there a way we can do this in here as itself? Can we do I comma character and enumerate path, and then we'll say if it is a character or I is equals to the length of path minus 1. In either of those cases, you need to run. Okay, I guess this does not work well here. We need to perform a final check of this whole thing. I know this is repetitive. Let's see how we can improve on that. But for now, it seems to work on the test cases. Let's try submitting it once. It works. Now we need to figure out a way to simplify this. It doesn't look that good. So we have our directories, which is initially empty. Then we have our current directory. And then for each character in path, we say if it is a character, that's a slash. We consider things here that if you have a dictionary, if you have a current dictionary name, perform operations as specified, and reset the current directory to empty. Else, you just add a character and move on. Instead of doing this, maybe what we can do is we can say if the character is slash, then you don't, if the character is not slash, you insert a character, right? Don't insert slashes. And then if the character is a slash or it is the last position, then we can do this whole thing. This will allow us to get rid of this whole thing, or we need to enumerate again. I is equals to the length of path minus 1. Then we do this whole thing. We check if there is a current directory and blah, 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 blah. We can directly return this thing as well. We don't need separate thing here. Let's try running this. It works on the test cases. Let's try submitting it. It works. a bit slower because maybe we are doing again and again 2 checks, but it's okay. Let's see some solutions what other people have done. They're creating a stack, and then they're splitting things. They're pushing and popping, and then appending like this things in string. So I guess this is a good solution. And this today we were able to solve 2 questions. I started late and I have to end early today, but we were able to solve 2 questions today from the stack list. One was easy, valid parentheses, and other one was simple path, simplified path. Tomorrow I will try to continue with the minimum stack and the evaluate reverse polish notation. And then we will move on to the linked list questions. Hope you guys enjoyed today's session. See you guys tomorrow.